Here in this paper, I will present in state of Dr. Susan B. because it has special situation. She cannot attend the conference. So this presentation is about pseudo-random number generator based on 4D hyperchaotic system, Riedel basin of attraction, and advanced microfluidic technology. This is the agenda that I will try to present. As an introduction, all of us know what is a pseudo-random bit number generator. It's critical in various fields such as statistics, computer science, cryptography, gaming. All of these applications needs a pseudo-random bit generator. So to generate sequence of number that mimic the properties of random number, starting from specific initial point and using some mathematical formula. As of all of us know that there is linear and nonlinear functions to generate this pseudo-random sequence. So when you use linear type, the generated sequence may be weak, but when we use nonlinear type, we obtain a very secure or a very close to random sequences. There is many types to generate, many media to generate the PRNG. One of them is the LCG, and the other is linear feedback shift registers. These two approaches are well known for generating PRNG. We know that they are simple in implementation and making them less secure for cryptographic application because it's a linear feedback shift register. So the generated sequence may don't have long distance. It can be short distance to be predict easily. So in this approach, we also used chaotic system due to its properties. So to ensure that because the properties of chaotic is except ergodicity, which is statistical properties, ensures the randomness, and to ensure also sensitivity to initial conditions, the main property of any chaotic system, and a wide range of behavior. So a traditional chaotic PRNG often face issues such as predictable and degradation and has low dimension system. Our aim here to address this weakness by developing high dimension chaotic system and integrate innovative techniques like microfluid. Here we used microfluid as a new technique to hybrid with the chaotic system to ensure more randomness for these sequences. So due to a limited shorter period of the PRNG that generate by linear feedback shift register and the other approach, and low dimension chaotic system, so here we use PRNG based on chaotic system. This will accept predictability and degradation, and randomness, where the challenge is the security and unpredictability and efficiency are crucial for cryptographic application. So in this work, we propose 4-dimension chaotic system and develop a robust PRNG using proposed hyper. This system is hyperchaotic. It is has more chaoticity than the normal chaotic system. Hyperchaotic means it has more than one positive Lyapunov exponent. And we use this algorithm, Fisher-Yates shuffle algorithm. It's a known algorithm in microfluiding technique. So the objective of using this technique is to enhance the randomness and the predictability to ensure high sensitivity to initial condition and pass the randomness test, the known randomness 16 randomness test, NIST. The combination between hyperchaotic system and microfluiding technique is used to generate the random sequence and mix between the mentioned algorithm, Fisher-Yates shuffled algorithm. Then we analyze the output, the PRNG sequence, using the statistical test. This is the proposed system, 4-dimension. And also we show the chaoticity of this proposed system. Here is the faceplane and the attractor and the simulating circuit of the proposed system. Here is the attractor of the proposed system, and we give the values that give that can obtain good chaoticity signals. And here is we show in this test by Lyapunov exponent that this system is very sensitive to initial condition. This is the faceplane of the proposed system. And this is the bifurcation one-dimensional graph for the bifurcation diagram. And this is the entropy of the system, of the proposed chaotic system, to show that its chaoticity properties. And the Poincare map, all of these are evaluated for the chaoticity of the proposed system. And here we show mathematically the Bayesian of attraction by finding the fixed point and then show that where is the Bayesian of attraction. And here also the addition, mathematical derivation for the Bayesian of attraction. And here is the graph of them as a result. And the microfluiding technology, it's a technology or a manipulating small amount of fluids through tiny channels. So it's used to investigate interaction between a drug carrier and cell and the effect of active component and the drug is aiding in the developing of a new treatment. So it's crucial in fields like chemical analysis, biological research, diagnostic, and material development. Many of these fields used microfloating as a technique to enhance their work. It allows for miniaturization of lab process, reducing reagent and sample volume. It speed up experiment and enable high thorough testing and analysis. It's also a technology can be adapted to mix random number sequence from chaotic system as we use it in this work. Here are the algorithm, the proposed method to generate the signals or the pseudo-random from the proposed chaotic system, and then use the microfluidic to mix these 4 generated sequences in order to obtain PRNG have high statistical properties. Here is the flowchart of the algorithm used. Begin by proposing a hyperchaotic system and then generate sequences, 4 sequences from this system, and combine these sequences with the based on the technique used in microfluidic. Then continue until get a new PRNG, and we test this PRNG statistically. Here is the algorithm. The first one is generating the initial value, and here the combination of the sequence, the 4 generated sequence, and here using the Fisher-Yet show algorithm, which is a microfluidic algorithm to combine these 4 generated sequence. And here we obtain PRNG, the algorithm to obtain the main PRNG. And here is the NIST test, the 16 randomness test, to show that the generated sequence will pass all of these statistical tests. And here is the analysis of the generated sequence. We show that it is very sensitive to initial condition, this sequence, and the sensitivity reach 99.5. Here is autocorrelation and cross-correlation evaluators for the generated sequence and the entropy. And as a conclusion, we introduce a new way for generating PRNG by combining microfluidic technique with the 4-dimension hyperchaotic system. We utilize 2-step process, generating hyperchaotic system, and mix them using the Fisher-Yet shuffle algorithm. The performance of the algorithm is evaluated through NIST tests. And, this is some of the used references, and thank you again for your attention.
Thank you for your presentation of the paper, which has presented a new mode of PRNC sequences by combining macrofluidic techniques with the hyperchaotic systems of n dimensions. Are there any questions you would like to have for this paper, please? I would like a point.
Yes.
Question.
Yes, Dr.
What are the mathematical contributions considering linear congruence generators, inverse congruence generators, as well as PRNC sequences?
Yes, PRNC sequences is very important in many applications, especially in cryptography for security purposes. So improving or obtaining good PRNG sequence with high randomness properties, it's a challenge. So using a new approach, new mathematical approach in this field is a contribution. So the main mathematical contribution is using a chaotic approach to generate this sequence. And here we propose a new chaotic system, and we prove that this system has a high chaoticity property. So ensure this to ensure that the generated sequence has high random properties.
Are there any further questions about this study and presentation?
Question?
Yes, please.
I'm so hardware guy, so something different from your area. But usually the random number generator is very important for many areas. So for instance, about the communication.
Yes.
The communication is very
Yes,
important.
sure.
So
Yes.
usually in such area is random number generator is hardware implementation. So your method, like your proposal method is available for the hardware.
Yes. Thank you for your question. Actually, we here used simulation, not hardware implementation. It is difficult for mathematician to go through a practical application. So here only we use simulation, like programs, to generate this sequence and prove it's a random sequence generator.
Okay. Thank you very much.
Thank you for your question.
If there are no questions, we can proceed. I guess, thank you.
Thank you.
Next in our workshop, we are going to listen to the presentation for the paper authored by Nguyen Ha Huy. The title of the paper is Solving Maximum Cut Problem with Multi-Objective Enhanced Quantum Approximate Optimization Algorithm. Yes, Dr. Nguyen, you may kindly start, please, if you are ready. Okay.
We can try to I
Okay.
you don't see now. Yeah, I know, but I can't. I don't know very why. Okay.
Yes.
Okay, just a second. Okay, I am sharing. Okay, I do full screen, but I don't see the full screen. Yeah, but okay.
Good morning, everyone. My name is Sven. Today I will talk about my topic on solving the maximum cut problem with multi-objective enhanced quantum approximate optimization algorithm. My talk contains four parts. First part is introduction, which I talk about some details of the quantum approximate optimization algorithm. The second part is our approach to improve the performance of the QAOA, and the third part is numerical simulation. This part is shows the distribution of value from the quantum circuit, and the fourth is the conclusion.
So, okay.
Okay, first is the introduction. I will talk about the overview of the QAOA. This algorithm is hybrid quantum classical computer algorithm for solving the combinatorial optimization problems. And this algorithm is used for many combinatorial and binary optimization problems, including the maximum cut, portfolio optimization, and many other combinatorial optimization problems. And next, I will talk about the component of this algorithm. This algorithm contains first is a step function. This step function is constructed from the exponential of the complex matrix. The first matrix I introduced is cost operator. This contains all the value of the problems, including non-feasible and feasible solution in case of constraint problems. The second is with the Hamiltonian operator. This operator will show how the solution can transform within one flip, and I will introduce it later in the next slide. And this is the procedure of optimizing the quantum approximate optimization algorithm. First, and we can see that the quantum computer is used for storing all the solutions in binary strings, and the classical computer used for optimizing the quantum circuit parameter. It optimizes when the expectation of the algorithm close to the optimal solution value. And the role of the Mr. Hamiltonian operator, it represents the solution transition. For instance, we have the solution here, 1, 0, 1. It can transform by using this matrix. The HB, for instance, I want to transform this bit into 0, 0, 0, 1, and the distance of this and this can transform because this Hamming distance is equal to 1, and the second role of this operator is used for preparing the initial probability for all solution, including the optimal solution. Next, I will talk about this algorithm. Its advantage. First, it requires a large depth layer. We can see previously on the process of optimizing this algorithm. It requires a large depth layer to find the optimal solution. Next is this can produce optimal solution with low probability with classical optimizer, since some algorithm like gradient descent, etc. And this only cares about finding a local solution instead of the global solutions. And some method like transform the distribution of the algorithm like a coordinational value matrix, and you can see in this article only makes the optimal value probability greater than 0 and cannot sure that this algorithm will converge in a low circuit depth. And next, I will talk about our method. Our method is first is a motivation. The first motivation is the disadvantage I talked previous slide, and the second is that if we only focus on optimizing only the optimal value probability, it can lead to some case like we cannot sure that it converges in a low depth, since this solution we see that it can only cares about the Hamming distance instead of the value of the binary string with the post function. And this is why I consider the multi-objective approach for this algorithm. First, I will care about the expectation value, and the second is the optimal values probability. And next, I will talk about the advantage of this method. It can control the transition between solutions, increase the transition between probability between near optimal and optimal solution, and decrease the transition between low quality and high quality solution. And the second is it can help us to explore more parameters for the quantum circuits instead of just one trajectory of the classical optimizer. And finally, it ignores low quality solution and increase the high quality solution probability, including the optimal solutions. And this is and next I will talk about the algorithm we use for this reformulation. We use the NSGA2 for the QAOA with a multi-objective reformulation. And this is a process of optimizing the algorithm with the NSGA2. And in order to choose a solution from the Pareto front, we choose a solution that close to the that has the Minkowski distance close to the ideal point, such that both expectation and optimal solution value is close, since they are can conflict each other with log scale quantum circuit. In the third part, I will talk about my I will talk about the numerical simulation. First, we compare. First, I will talk about the solution I used to compare for our method. I use the genetic algorithm for compare the with our method. Next is backend of the quantum computer. We use the ICCSA simulator, and you can find it on the internet. And in order to compare two methods, we use the probability distribution, and the graph we use are taken from the constructing test function for global optimization using continuous formulation of the graph problems. And I use the Muscat instant. And this is a graph information of this of the data we use. And we only since the PCA are only suitable for low scale problems, we choose about 8 and 10 graph with a complete graph, and we have the following optimal solutions. And we also have the previous results. Next is the result. I show it in the probability distribution. We can see that with the genetic algorithm method, it can take the high probability of some low value like 0 or something in range 40, 460, 600. But the optimal solution happened right here is very low, has low probability. And next, we can see with the multi-objective approach, this increase the values that close to the optimal solutions, and we can see that our method has high fidelity in case in order to compare with the optimal solution probability, and is similar in case of the graph. We can see that it increases not only the optimal solution value, optimal solution probability, but also the probability of near optimal solution is much more higher. We can see with the genetic algorithm, it increase the increase the appearance of some far values than the optimal solution. And these are similar to the previous slide. And now it's for conclusion. We introduced our method to improve the classical optimization for the QAOA by using multi-objective reformulation with two objective functions, the expectation and the optimal solution probability. And we use the output distribution to see its efficiency, and we can see a significant improvement in probability of optimal solution and approximate radial with our multi-objective approach. And in the future, we will use this possible new method to improve the QAOA for solving the constraint binary optimization problems. And thank you for your attention.
Okay, thank you for your presentation, which is about novel approach to enhancing the performance of the quantum approximate optimization algorithm, which, as you explained, is a method used to handle combinatorial
Yes.
optimization problems.
Yes.
Yeah, right. If anyone would like to ask a question, please go ahead.
Yes.
Yes.
Yes, please. Where is the application of this optimization algorithm?
This sorry, is what is used for solving the combinatorial optimization problems.
For computer
Combinatorial binary optimization problems.
for binary optimization.
Yes, it's used for binary optimization problems.
For example,
For example, the unconstrained binary, the quadratic unconstrained binary optimization problems, including the maximum cut. You can find it on the internet. This maximum cut in case of binary formulation and some other things like that.
yes, thank you.
Thank you for the question, for your answer. Can I ask a question?
Yes, okay, thank you.
Okay. Can you give me more details about the disadvantages and limitations of your novel approach?
As the,
More details about the disadvantages
of,
and limitations of your novel method.
my
Do you have
method.
any limitation?
Yes, of course. My method, I haven't said to you the disadvantage. The first disadvantage is required. When we increase the size of the problems, it can increase the time computing. It's much more high. We have to wait about 1 hour to find a good solution.
Okay.
It's about time, but analytically, it's good for improving the performance of the algorithm. But in general, the optimizing this algorithm we can prove, and there is an article prove this optimizing this algorithm is an NP hard problems.
Okay. Thanks a lot. Okay, dear participants, we can now more onto our next presentation at our workshop. The title of the paper to presented is Designing and Implementing 2D Integer DCT Hardware Accelerator Fully Compatible with Versatile Video Coding, and the co-authors are Nuho Huang, Nguyen, Tan Pat Deng, Trong Tuch Huang, and Tu Tuan Yong. If you are ready, you may please kindly start delivering your presentation.
Line.
Okay.
Okay, thank you.
Okay, give me 1 second. I share you with the class.
Can I start?
Okay, now we can see you. Do you hear me? Do you
Okay.
hear?
Yeah, I hear you.
Okay, you can start.
Okay, thank you. Hi everyone, my name is Hoàng. I'm from Faculty of Electronics and Telecommunication, University of Science, Ho Chi Minh City, Vietnam. So today I'm very happy to be here because I have a chance to present about my paper, designing and implementing 3D integer DCT hardware accelerator fully compatible with versatile video coding. And my presentation is divided into 4 parts: background, implementation, composition, and conclusion. Vector video coding (VVC) were announced in 2020 as the more recent video coding standard, and it was developed by the video coding expert group and moving picture expert group, and it can support resolution up to 8K. Uh, an important part in video coding is this day, but it's your floating point, which is slow and take more research to run. So the solution to your integer density, we just multiply by integer. The formula one is general formula for this integer density in which the Cn has some properties such as even row has symmetric about the center, all row are symmetric but flip around the center, and larger size matrix emerald and the matrix of small size. Uh, Therefore, we can separate for Formula 1 into Formula 3, 2A and 2B with lower complexity. Here is the example about calculating distance 1D for 8 points, and the red line is the center. Uh, Applied in this formula, this expression can be separated into uh, expression in 2A and 2B. Uh, and expression 2A can also be separated into 3A and 2B. Apply this knowledge about integer density just recent. We propose the architecture as shown in Figure 2 that has three main blocks: control block, density 1D, and transport memory. The control will control the operation of the system, and density 1D will compute 1D density. And the last transport memory will convert row to column. The input coefficient will go to density 1D, and after that, the data will go to transport memory. In here, the transport memory will convert row to column, and the output will be go to density 1D again. Finally, the output of density 1D here is the output coefficient. Figure 3 is the architecture of one this step that I have three main steps, including ASUP, OS, and R step. The first is ASUP architecture that will generate the A matrix A and B in formula 3A, 2A, and 2B. The result of this step will one will send to the up block, and one will the other is directed into n hop form with the same architecture but the smaller size. Uh, the next is out step that will relate the multiplication in 2B with the addition and shift. And it take only two clock to complete. And if we can change the size of the multiplier, if it cannot calculate in two clocks, here is either disable 90, uh, 90 and 87. We change the size with this. Uh, Finally, the add step conduct addition or subtraction operation between the element of the result matrix from the of step, and we use binary at the trees, and we must the subtraction operation to minimize the number of subtraction, so that its output result is compute from the different other circuits. And for high performance, we use pilot architecture that contain ASUP, OR, and as step, and addition row state to row and reside the output coefficient to 16, 16 bits. And for this architecture, the calculate 1D density for first 64 points using only 10 cycles. Uh, the last block in general architecture is transport memory, and here is the example for transport memory 8 points, and we use a single program arrange in an array, and when writing process, we will each row of the 1D density result is sequentially written into temporal memory along the forward diagonal, starting from the main diagonal. When reading from transport memories, the second round of the 1D density calculation on a gram are reached at the same address. Here is the result when synthesize our proposed architecture on FPGAs, and that support size ranging from 2 to 64, and that can handle non-swap block, and in static 10 chip, uh, m- our architecture can support video solution up to 16K and 60 fps. In the comparison, our proposed architecture only supports size ranging from 2 to 32 for comparison with other architecture. Uh, in my architecture, the arc and art step are designed to minimize the number of clock cycle and use the biologic techniques to speed up the 1D DC step. So you can see here they achieve a higher frequency and higher throughput, but with more results. For conclusion, the high 3D integer density hardware accelerator were implemented and optimized on an FCA, focused on supporting the VPC video coding standard, and our proposed design has demonstrated efficiency and flexibility and in handle the complexity introduced by VPC. And the last, our design also support previous video coding standard and accommodate the advanced feature of VPC. My presentation will finish. Thank you for your listening.
Thank you for your presentation where you have addressed implementing and optimizing a 2DCT hardware accelerator to provide an efficient solution for the H.266 video comprehension standard. You have provided the competitive advantages of this accelerator compared to previous standard. Would anyone like to forward a question related to this paper and presentation? Okay. I would also like to pose one question.
Yeah.
Yeah. What are the limitations of the 2DDCT hardware accelerator?
Sorry, I can hear a of the question. Can you repeat?
Okay, what are the limitations of two of the 2DDCT hardware accelerator?
Uh,
What are the
what?
The microphone is here, I don't.
Oh, sorry,
what are,
the sound not clearly, so I can hear that
okay,
clearly.
okay.
Can you
What are
chat
the
in? Can you chat in the message in chat on chat?
okay? What are the limitations?
Mute.
Now,
No.
from
Do you have any limitations for the 2D the software accelerator?
Okay, maybe you asked about the invention in my design. Okay, I designed the first of all I designed the as hardware accelerator fully compatible with visual video coding, and it's the reason it is were at the most recent video coding standard.
Yeah.
We have not web block, and it's the transport unit up to 64 points, and in a high efficiency video coding, it just supports 32 points. Yeah, but in implementation, uh, design we design out step and out step to minimize the and we apply parallel architecture to for high performance uh, and it can and it can support the VPC video coding standard, um, and also support previous video coding standard. Maybe okay. Maybe my answer can wait for you. Uh, Sorry. You can hear that.
Yes.
Yes.
That's all I want to share with you.
I don't understand.
Yes.
Okay, thank you for your responses for the presentation. Dear participants, let us now listen to the last presentation of our workshop today. We are going to listen to the presentation about the work entitled Internet of Things Implemented with Ruby, written by Hatabat Silangam and Kazuaki Tanaka. You may please start presenting your presentation. Okay.
Can you give me the present? Yes, thank you. I don't know. Okay. Which is this this which one? Okay. So we can copy. Okay. Second. Okay. Give me 1 second and close. Give me back the speed. Okay. Just a second, I screen with the chat. Okay, you can start. Yeah, yeah, of course. That's it, right? Okay, perfect.
Hello, everybody. My name is Dr. and I'm from Tanaka Laboratory Department of Creative Informatics, Kyushu Institute of Technology in Japan. Today, I'm proud to present my research, which is Internet of Things implemented with the AUV. So let's talk about the background of this research paper. Okay, currently now in Thailand is IoT system is developed rapidly in Thailand, but also in a smart farm system. But it's not this system, the smart farm system is not much in Thailand because various problems such as the cost of tool and the production of the from the smart farm system is not clear. It is not worth to the investment. So in our research, we try to provide to solve this problem to create the low cost system and easy the farmer in a farm can easy to use this system, easy to understand, and this in this IoT system we try to include the limitation of the this system to include the LoRa to provide the limitation of the IoT system. So let's talk about the objective of this research. First is we design the Internet of Things system implementing with the mRuby, and second is we create the mRuby library that support the operation of the Internet of Things, and the second is Internet of Things that we design we will increase the limitation of the Internet of Things by implemented with the long line communication to help the this system more than communicate more than not only the internet. So let's talk about what is the Internet of Things. In this picture, provide the component of the Internet of Things. The Internet of Things refers the thing can connect the internet or the linking of the device can connect the internet to the cloud to share the information between the device. And in our research, we also focus on the embedded system in the IoT because the embedded system can be a part of the Internet of Things. Normally, the embedded system not necessarily to use the internet, but the internet, the embedded system in the Internet of Things necessarily have because this embedded system necessary to share the information between the other system. So which microcontroller is used in this embedded system is ESP32 because ESP32 is low power, low cost resources, and suitable for use MOV. And this is a framework, the development frameworks for the ESP32 is necessary for create the firmware to the ESP32. And this slide I will show you how to set up the ESP32 is development framework for the ESP32. Is I set up this framework on the Ubuntu because it's easy to use tool and command to create the project for the ESP32. And this is a directory for the ESP32. We focus on this component. This directory can be include the third party from the other project as a mruby. We can include the mruby into this directory to be the main C. This is the main C can be included the library to operate on the ESP32. And what is the mruby? mruby is an implementation of the Ruby programming language try to be a lightweight and suitable for the embedded system and IoT device. And this is show the software implementation, the overview of the software implementation. After we set up the developing framework for the ESP32 and include the mruby into the component directory, we can call the mrbgem. mrbgem is like a mruby library that have inside it has a C program that can access the tool and the library from the ESP32. And then after we already create this system, we can build the application to the ESP32. And next, let's talk about the overview of the IoT system. In this system, we design for the smart farm system that include various peripherals that include the LoRa module. What is the LoRa module? LoRa is a low power module. Is mainly used in the Internet of Things, and long range is also advantage of the LoRa. LoRa can be communication more than 10 kilometers in the open space. And this system also includes the various sensors such as the temperature sensor, light sensor, and soil moisture sensor to record, to monitoring the animal in the smart farm system. And this system also will separate the work operation in this system into parts. First part is communication between other system, and second is data visualization on the monitor. So in the smart farm system, we set up into the client and master node and communication via the LoRa module and the client node. This node responsible for the monitor the data from the environment, and this node we set up this node for controlling the water system, and the master node responsible for making the decision to control the water system and send the data to show on the monitor. And this is node one. Node one is responsible for collect the environmental data and to send the master node. After that, the master node will analyze and show on the monitor. And this node also is designed to send the message to turn on and turn off at the node 2. So after we prepare this overview of the smart farm system, we can try to make an experiment and correct the result. After we create the overview of smart farm system. We try to implement the various sensor and the light sensor, temperature sensor, water pump to control for the water system and the LoRa module for the communication. And this is a software implementation. In this picture, provide the mruby program. This is a mruby code. Normally, for control the ESP2, they use the C programming language. In our research, we try to provide the easy programming. That is easier programming is a Ruby program. Is the first part of this code, we try to include the MRBGM, that is a library that can access the operation of the ESP2. And then this we design the function for the LoRa module to set up the LoRa configuration, set up the number of nodes and the number of the network. And this is a function for read the value from the data from the sensor. I already created this function that make it easy to use in this code. And then this code will combine the data, the value from each sensor combined into the one string format and use the LoRa function to send the message to the master node. And after this video provide the operation of this system. This is a video from the node 1. After the node 1 send the message to the node to the master node. The master node will analyze and separate the data into T type. First type is temperature sensor, second type and light sensor, and third type is soil moisture. And this node will also send the message via the LoRa module to the node 2 to control the system. And this node also use the Wi-Fi and MQTT to publish the data to the MQTT broker. And after the ESP2 publish the data to the node, to the MQTT broker, the node net will subscribe the data from the broker and show on the InfluxDB. In this video, provide the result of the smart farm system. These are our IT system that show inform the line graph and the gate view. Line graph provide the data from the previous time, and the gate view provide the data at the time. So in the conclusion, we after we testing smart farm system, we have conclude the operation of this system into two parts. First part is the hardware operation. The ESP2 can work with the peripheral device that connect to the ESP2 in the real environment, and the software, the mruby, can embed it into the ESP2 and can call the mruby library that can access the data from the device. And overall, this system has the potential for use in the smart farm system in Thailand, because this system can be communicated use that area without the internet using the LoRa module, and the LoRa communication is secure because in this module require the password to access the data. And in the other thing in this system, we implemented with the mruby, which is simple programming language that secure to control this system and easy to use. And the last section is future plan. In our IT system, not designed for the smart farm system, it can implementing in many applications. This, for example, this application is a smart fire prevention to solve the problem in Thailand, because every year in Thailand we have forest fire. So we can decide implementing with the LoRa, because in the forest very difficult to use the network for the internet. We can use the LoRa module to create a multi-network for monitoring the forest, and use the temperature sensor, fire sensor, and light sensor for to record the emission from the forest. And so in our research paper, we try to share to provide the alternative choice for users who are interested to use the IoT system that use mRuby that's provided easier for previous that use the C programming language that's very complicated. We try to provide Ruby that's simple to write, that automatic way for user to access that.
We thank our colleagues for their work, which addresses the development of Internet of Things system using fusion sensors implemented with Ruby, a lightweight implementation of the Ruby programming language specifically designed of microcontrollers. Yeah. Would anyone like to forward a question to our presenter? Okay. Can I also ask a question, please? Okay. Could you please explain if there are other uses of Ruby language other than uses for microcontrollers?
Okay.
I mean, are there other areas of applicability?
Other
Yeah. Are there other areas of applicability?
this language
Yeah.
we have it other language.
First question, could you please explain if there are other uses of Ruby language other than uses for microcontrollers?
In other
Yeah.
yes because mRuby designed for use in the embedded system. For example, I use in our research we use ESP2, but if it also can use like a library Pi because mRuby has inside mRuby can inside this mRuby can embedded for the controller microprocessor that yes it can use other controller.
Okay. Thank you for your presentation and for your responses. Yes, dear participants and esteemed colleagues, this brings us to end of our workshop. On this occasion, I would like to thank each participant for their valuable contributions they have provided through their papers and the presentation they have delivered. Hoping to meet you all once again in the upcoming academic events. Thank you very much. Thank you. See you then.
Thank you.